Section 5.3, Dividing Polynomials. When you divide a polynomial by a monomial, you're looking at the divisor, and if it's one term, which confirms that it's a monomial, as in this example here with the 6x, we'll split the polynomial up and divide each term by the 6x. Then we'll reduce each fraction as follows. Yielding this result. The next type of division we'll look at is long division, or the division algorithm. And this is when you're dividing a polynomial by a polynomial. I've put on the left an example of integer long division to help remind you of the steps. The steps are the same for both types. We're looking at the first term, and we're trying to decide how it gets divided into the first term of the polynomial. And in this particular case, once we've decided that it's x that we're going to multiply by, we'll place it on top, making sure to put it above whatever term will allow us to have the correct number of terms below when multiplied. In this case, we've got two terms in the divisor, so we'll put it above the second term in the original polynomial. Then we'll multiply, just like in long division, and subtract like in long division. Now in the polynomial case, we need to make sure that we understand that that will change the sign of every piece or term in that multiplication answer that we've brought down. Then we'll compute and do the process again after bringing down that term, the -5. So we'll look at the x and the 11x, and we'll determine that we want to multiply by a positive 11, so we put plus 11 at the top and multiply and subtract, making sure to change the signs and calculate. When we have a remainder, we will place that remainder up next to our answer, adding it on, and the remainder is over the divisor. We'll try another one. Now here we have y squared plus 8 divided by y plus 2. We need to put a 0y in the y squared plus 8 to hold that position. Then we'll go through the process, deciding what to multiply by, doing the multiplication, and subtracting, making sure to change the signs. And in this particular case, that plus there becomes subtraction. And then we calculate, bring down the next term, and repeat. Remember again when we're subtracting to change the signs and calculate. Our remainder is then added over the divisor. Here we're going to look at another method called synthetic division. We can do this method only when our divisor is x minus k. So it does not have a power and it does not have a coefficient, the x. In this particular process, we take the divisor and set it equal to 0 and solve, and put our answer next to this tilted L that we've drawn. Then we'll place the coefficients inside the L and the constant as follows. Then we'll bring down the first number and multiply and place our solution in the next column. Then we'll add and repeat. multiply, and place our solution in the next column, add, and repeat. Now I've separated this last number because this is the remainder. Now we'll build our answer. We're going to put variables back in, and we need to make sure that we start with an x that is 1 power less than our original problem because we've divided 1x out. So this will look like 1x squared plus 3x minus 1. We also need to take care of the remainder the way we did in the long division problems. So our solution looks like this. Let's try another one. We'll set the divisor equal to 0. Place our answer outside of the L. List all of the coefficients and the constant. Note in this particular example, we're missing some terms. So we need to hold those places with zeros. The coefficients would be 0, and we need those placeholders. Then we'll start our process. Bring down the first number, multiply, and add, and repeat. And again, that last number is the remainder. We'll replace the variables, remembering that it's 1 less power than the original problem, so it will be an x cubed. And we work down in descending order, and then we take care of the remainder the way we did before.